if delta E naught cell is more than 0, then the correct option is, here we should check that they are talking about delta G standard value and the K equilibrium also. The formula for E naught cell is equal to 2.303 divided by NF RT log K equilibrium. Now let's check what is the relation between this delta G naught and this E naught cell. This is minus NF E naught cell. These two relations are here. And you know that this E naught cell, in the question it's given it is more than 0. It means it is positive. And if it is positive, then with the help of this we can conclude that this delta G naught should be less than 0. It should be negative. So this value is less than 0. And now if this E naught cell is positive, you can find out this K equilibrium also. This K equilibrium value, the equilibrium constant, is more than 1, where this value is given. If you check the given options, you will identify that these values, these two values which we find out here, are correctly given here in option 3. That's why this is the correct answer for this particular question. Now after this, question number 72 is here. Question number 72, standard electrode potential for Zn2 plus to Zn couple is 0.76 volt and for the Mg2 plus to Mg couple is minus 2.36 volt. The equilibrium constant of the reaction. In this case, the given reaction is this at 298 Kelvin, and what we need to find out here, we need to find out the equilibrium constant for this reaction. In this case, we should know that whenever we talk about E naught cell, that is equal to 0.0591 upon N log equilibrium constant. That's K equilibrium. We are representing it. Now what is this E naught cell? This E naught cell is equals to E cathode minus E anode. And in this case, we are considering this magnesium electrode as the anode while the zinc electrode as the cathode. So in this case, this value would becomes minus 0.76 minus 2.36. So it becomes plus 2.36. And if you solve this, this E naught cell value you will obtain with is 1.6 volt. Now, after this, let's find out the value of K equilibrium here. We know that this E naught cell is 1.6 is equals to 0.0591 upon. What is this N value? This is 2 log K equilibrium. What would be the value of this K equilibrium? It would be equal to, if you solve this, you will find that this value is 54.145. Now, this is the log value basically. And finally, you just want to find out the K equilibrium. This would be equal to the anti-log of this value. The anti-log of this value is 10 raised to the power 54. And here it would be 1.4. So this is the final answer. On the basis of this, we can choose the correct answer. That's option 1. That's why I'm choosing it as the correct answer. Now, further, let's take next question. Question number 73. Which chemical change requires an oxidizing agent? Zinc is getting changed into ZnO2 2 negative ion, Cl2 to Cl negative ion, nitrate ion is getting changed into ammonium ion, and MnO4 negative permanganate ion is getting changed into manganese ion. We know that oxidizing agent is required for the process of oxidation. So we have to choose the oxidation reaction in this particular case. And for that particular case, we have to check the oxidation numbers also. In this case, the oxidation number of zinc is 0 and it is getting changed into +2 oxidation state. Now, if we talk about Cl2, it has 0 oxidation number and it's getting changed into -1. The oxidation number is reduced here. Further, in case of nitrate ion, we have nitrogen that is in +5 oxidation state. Now the oxidation number of this nitrogen in ammonium ion is -3. While in case of this permanganate ion, the oxidation number of manganese is +7 and it gets changed into +2 in case of manganese ion. Now if you look at the given options, you will identify that only in option 1 is the process of oxidation taking place, because there is the change in oxidation number and that results in increase. In this case, it is getting changed from 0 to +2, while in other cases, like in the second case, it is getting changed from 0 to -1, here from +5 to +3, +7 to +2. It means there is a decrease in oxidation number. It means the process of reduction is taking place in all of these cases except the first case. So oxidation is only taking place here when zinc is getting changed into the ion ZnO2 2 negative. And on this basis, this process need an oxidizing agent, and that's why the answer for this question is option 1. Now after this, let's take next question. If oxidation state of A, B, C respectively are, if oxidation states of A, B and C respectively are +2, +3, -2, then the possible formula of the compound is. This is the question which you can solve on the basis of hit and trial. You have to place these oxidation numbers in the given compound, and the compound for which the sum of all the oxidation number is 0, that's a neutral compound, and that is your answer also. So if you check the option 4, the compound given in option 4 is A3, B, C3 whole twice. In this case, if you place the oxidation numbers, let me place here. The oxidation number of A is +2. 3 atoms are here, plus. B, this B has the oxidation number +3. Now, further, only 1 atom is here. And if we talk about C, there are 3 atoms. So 3 into, what is its oxidation number? It is -2. And whole twice you have to do. Let's check what you are getting here. This would be 3 to the 6 plus it would be 3 plus would be -3 into 2, and this value would be 0. It means only for this compound, the sum of all the oxidation number by placing here becomes 0. That is why this is the compound which is formed, and I'll choose it as the correct option. I hope this question is clear to you. Let's take the next question. Question number 75. Which molecule does not undergo disproportionation in aqueous alkali? So we're just talking about disproportionation reaction and the molecules which are given here as the given options. First, we should know what are disproportionation reaction. These are those reactions in which the same element get oxidized as well as reduced. So simply, if we talk about the given options, we have to look at these molecules, and these should be oxidized as well as reduced both. So suppose I'm talking about phosphorus. Its oxidation state vary from -3 to +5. What does it mean? It means in case of P4, its oxidation state is 0. It can reduce its oxidation state and it can even increase its oxidation state also. It means it can oxidize and reduce both. That is why this is not the answer for this question. Now, we have the next molecule, that is S8. Again, the oxidation state is 0. And if we talk about sulfur, its oxidation state is variable. The minimum one is -2. And if we talk about its highest oxidation state, it is +6. Now, it means it can both oxidize and reduce. Now, if we talk about the next element, that is Cl2 in the 0 oxidation state, and it can also vary its oxidation state from -1 to +7. If we talk about HClO4, there its oxidation number is +7, and if we talk about HCl, there is the oxidation number is -1. It means it can have the variable oxidation state. It means it can oxidize as well as reduce. But if we talk about F2 molecule, the oxidation number of fluorine is -1. It means it can only reduce its oxidation number. It cannot increase it. It means this F2 has the only nature to be reduced, not to oxidize. And if it is so, it will not show disproportionation reaction. And that's why I'm just going to choose here option 4 as the correct option for this question. And yes, it's a turn for question number 76.